Hello everyone. Today I will discuss how we can replace the costly counter electrode of dye-sensitive solar cells by the waste paper. So this is the part of my 2 weeks online national level faculty development program projects, and I have to present this 10 to 15 minutes presentations video for this purpose of successful completion of this online national level FDP programs. This program is on NEP 2020, possibility potential of national education policy 2020. So here first you know what is the dye-sensitive solar cells. Okay, and here in my labs we fabricate the solar cells, different types of solar cells like perovskite solar cells, quantum dot solar cells, dye-sensitive solar cells, and these types of the different solar cells we fabricate, and then finally we study the performance of the solar cells, and then we apply the solar cells for getting the higher efficiency and the electricity from this recycle waste material, using the recycled waste material in the solar cells. So now I will discuss how we can easily fabricate these solar cells by easily available raw material for the applications of these solar cells. So here if you see this PPT, the recycle waste paper, a new source of the raw material for counter electrode as replacement of platinum in dye-sensitive solar cells. If you see this diet, and I am Dr. Subhashish Rai, Assistant Professor, Department of Chemical Engineering, University of Calcutta. So my topic will be covered first introductions, then what is the solar cells, then objectives of the research, then literature review, then fabrications of counter electrode DSSC, then hybrid device of the perovskite with TEG, then perovskite solar cells fabrications characterizations, and different types of characterizations I will describe. UV visible, then structural characterizations, scanning electron microscopy, XRD, electrical characterizations, then conclusions and future remarks. Okay. So why this solar cells is very important? So if you see nowadays the air pollution leading a global warming, and it is increasing day by day. So we are searching this alternative source of energy, and in different types of the renewable energy, solar energy is most important source of renewable energy, and we can use this energy for easily it is easily available and low cost, and also for sustainability. So in the solar cells materials, when you see, we can make the different types of the flexible solar cells by the different way of formations. If you see here, this is the amorphous silicons, then this is the gallium arsenide, this is the cadmium telluride, and in the left side this is the working mechanisms of the solar cells. So here you see the n-doped region and p-doped regions. In the n-doped regions you see the mechanism how to hole and electrons propagate, and it's moved to different directions and produced electricity by utilizing the solar radiations. Okay, so here if you see the specific objective in our study, when we fabricate the solar cells in the lab, it has counter electrode and working electrode, and both electrons is working very costly. In particularly in the dye-sensitive solar cells, we can replace this costly counter electrode by easily available material. Here our attempt is to replace this by the paper-based electrode, which will be coating on the top of the carbon and making this for conducting as a conducting electrode. So after fabrication, so different types of the study we will do. We have already done this UV visible, and the scanning electron microscopy, then XRD, then finally different types of electrical characteristics. So in the literature, if you see what are the perovskite material, perovskite materials is a material that contain different types of the metals with AbO3 structure. That means, as example, CaTiO3, this is one sort of the perovskite materials, and the chemical bonding of the perovskite materials, if you see, these types of the bonding is there. If you see different types of the perovskite material, organic, inorganic, hybrid, all types of the materials is available. So if it is like PbTiO3 or inorganic, organic material, here in the middle lead atom will be there, and based on the size of the material, it's occupied different type of positions. If it is inorganic, organic material combinations, then methylamine will be the corner of these materials. So these structures is called the perovskite materials. So in the nowadays, the perovskite materials is shown very high efficiency compared to the other dye-sensitive solar cells or quantum dot solar cells. So for these reasons, these perovskite materials is very important nowadays, and fabrication of perovskite materials is very easy, but in the open conditions the fabrication process is very tough. So if you see the literature, different types of the perovskite synthesis process is there, as the different types of perovskite materials is available: inorganic, halide, instinct, doped, alkaline. These types of perovskite materials are there. We can fabricate different types of these types of the perovskite materials, and we use this material for fabrications of the dye-sensitive solar cells or other perovskite made solar cells. So here, if you see the trends of the evolutions of the solar cells efficiency, the perovskite solar cells is very increasing nowadays for the applications of the solar cells market. Why? Because the efficiency, it is reached a maximum nowadays, is reached around 26% nearly, and it is going rapidly increasing. So that's why people are using this material for the applications of the solar cells. So now if you see, when you make the perovskite solar cells, and in case of the dye-sensitive materials, there will be different types of the electrode. So there will be the very important to maintain the band gap design properly, so that there will be no recombination loss, and there will be the higher efficiency for the solar cells. As an example, the perovskite solar cells, you see the structure, top is the silver, which is one of the contact, and bottom is the FTO, fluorine of tin oxide, and middle the line different types of perovskite material, electron transport layer, hole transport layer. So here we can see in the dye-sensitive solar cells, there will be no counter electrode. Here there will be there will be the platinum based electrode, which we will replace in our case later. You see how we replace this PT electrode, and we replace PT with carbon based carbon coated paper, which is easily available, and a waste material. So it is one sort of the applications of the waste material for the applications of the solar cells. So you see different types of process of the fabrications of the solar cells. We used to use this perovskite solar cells fabrication process by the spin coating techniques. Then finally, these types of the films we used to get on the surface of the FTO, and then finally we coat on the top by the sputter coater, using this sputter coater, and this is the silver paste or gold coated top electrode, and there will be the bottom electrode. So from here we get the contact, and finally it measures different types of parameters of the solar cells. So in the photoanode for the dye-sensitive solar cell schematic diagram, if you see, initially we take the waste paper, then waste paper put in the solvent, then with solvent we coat the conducting carbon paste on the we mixed with this paper with the conducting carbon paste, then we put into the dye these things, then these things we coated on the surface of the FTO glasses, then finally we put into the whole things to the autoclave for drying, and finally we get this counter electrode and working electrode, and then we combine this, and finally these types of the fabricated solar cells formed, and we check the performance of these fabricated solar cells by the by the instrument of which get the electrical property of the solar cells, like electrometer or high impedance analyzing meters. So here if you see different types of parameters, the absorbance first one of the important study for the solar cells, so that we can check how much solar radiation absorbed on the surface of the solar cells, and from here we can get the band gap of the solar cells. We calculate the band gap, it shows the wavelength or range of the wavelength which it can absorb. Then finally from here we calculate the proper band gap of the solar cells, and this is the microstructure we have done from the scanning electron microscopic of our electrode. Then this is defined as the pattern formations we got from here. Then the XRD analysis, which confirm the presence of the perovskite material in the bottom of the solar cells. Then finally the perovskite cell fabrication process we have done. This process is show the current density versus voltage. Here if you see we defined as the parameter like VOC, JC means current density, open circuit voltage, short circuit current. All those parameter we check from here, and then we tune this parameter to check how the temperature affect this parameter. So here you can see from 20 to 40 degrees centigrade we change the temperature, and finally we check the parameter more or less stable at the defined temperature up to 40. So here from here you can see from 20 to 40 degrees temperature difference, there is no such changes of the perovskite or the solar cells parameter. So here from we can conclude that by the temperature effect there will be no change of the perovskite, so it is much more stable than this other parameter. So here we can conclude our recycled waste material we can use as a counter electrode with perovskite materials in dicing solar cells, and from this parameter we can evaluate from here, where we get around 8% efficiency from these solar cells. Though this efficiency is less, but the cost of these solar cells is much more less, as it is we are used this recycled paper for making this counter electrode. Finally, other different characterizations of the electrical properties we have checked from the solar cells, which shows up to 40 degree, and different repeatable cycle we have done up to 40 degree, which shows this is much more stable than the other reported solar cells. So here we can finally conclude that we successfully developed the counter electrode as a replacement of the platinum in dicing solar cells. Excessive surface temperature in the perovskite solar cells change the lattice constraint of the material and causes stress and strength with the sandwich structure of the hybrid device. Incorporations of the tetraethylate modules at the backside of the perovskite solar cell provide thermal stability as well as enhance the output performance. Incorporations the TEG backside of the PSC use the low grade heat energy and convert the temperature electricity, and also the hybrid PSG TEG with recycling waste material used counter electrode can give the stable solar cells, dicing solar cells with paste of the perovskite material and is stable up to 40 degrees centigrade, and we can achieve up to 8.52 degree centigrade 52% efficiency. Also we can conclude these things that in future application